Everybody. Today we will discuss the addition reaction to cyclopropane ring. And the most of the reaction of the cyclopropane ring are very much similar to that of the alkene. And in most of the reaction, the cyclopropane ring will open. And we know that the Bayes strain theory. And according to Bayes strain theory, the cyclopropane ring is a strained system having the bond angle of the 60 degree. And for the normal tetrahedral bond angle is 109.28 minute. So here the interorbital angle occurred in the cyclopropane ring is 105 and the internuclear angle is 60 degree. So every bond CC sigma bond in a cyclopropane ring are highly strained system, and there are angular strain and torsion strain is also existing in cyclopropane. So that's why in order to combine the CC in order to form the CC bond in cyclopropane, the bond has to the orbital must have to close to each other. So the majority of the bond is similar to banana. So that's why this bond is known as banana bond. And due to this strain, the CC bond have a more P character. That's why the ring is highly strained system. So we can easily break the CC sigma bond in cyclopropane. Now, in cyclopropane, most of the reactions occurs very easily. For example, HBr addition, hydrogenation in presence of the catalyst, and the hydration and halogenation is possible in cyclopropane ring. See here the cyclopropane ring, if you are adding the HBr, the hydrogen is added in one end of the cyclopropane and the bromine is added in the other end. So the substitution occurs in the terminal position. So similarly in the hydrogenation in the presence of the catalyst nickel, the reaction occurs at very low temperature 80 degrees Celsius and the cyclopropane ring converted into propane. And similarly if you are adding the water in the presence of acid as the catalyst, the hydration will occur and chlorination occurs in the presence of the Lewis acid FeCl3. And now these are the some of the reaction which occurs in cyclopropane ring: chlorination, even in the dark, and the bromination, HBr addition, nickel hydrogenation, and sulfuric acid reaction, and which KMnO4 does not give any reaction and HI give the iodination. Now we are moving into the different type of the addition reaction in cyclopropane. There are three type of the addition reaction occurs in cyclopropane, that is electrophilic addition reaction. That means electrophile is started the reaction. Next is nucleophilic addition. Here the nucleophile will start the reaction. Next is the radical addition. So consider this example in which one of the vertex of the cyclopropane are substituted by the methyl. Both the substituent are methyl. In other vertex, one of the substituent are methyl, other is the hydrogen. In the next carbon atom, two substituent are the hydrogen. So if you are adding HBr, the rule follow for the addition is the Markovnikov rule. So hydrogen will attack in the less substituted position. Okay. Now we are moving into the mechanism of electrophilic addition reaction. Consider this is the cyclohexane ring and cyclopropane ring in which one of the carbon is substituted by the R. And if you are adding an electrophile H+, the H+ will attack in the one of the least substituted carbon atom. So a carbocation is generated and this carbocation is is shifted to the more substituted carbon because the carbocation stability order is in the range tertiary greater than secondary greater than primary. Now, sometime it may again shift to the next carbon atom, but in most case the most substituted carbocation is more stable. So in that position the nucleophile will attack and the final product is formed. There are one more type of the mechanism is available in electrophilic adhesion reaction, and H plus is added in between the two carbon atom and a cyclic carbocation is generated. After that the nucleophile will attack and to form a form the product. Okay, now we are moving into the nucleophilic addition to a cyclopropane. First of all, the nucleophile will attack the less hindered side and to form a carboanion, and this carboanion is stabilized by the electron withdrawing group, and after that the electrophile H plus is added, then we will get the product. Naturally, nucleophilic addition reaction is possible only when the electron withdrawing group W is present on the cyclic ring. Next is the free radical addition to cyclopropane. So first of all, the radical generation occurs. That is the initiation step. After that, the bromine radical is added into the less hindered side. So the most stable radical is formed here because the stability order in the case of radical is also in the same order of the carbocation, tertiary greater than secondary greater than primary. So here the bromine, if the bromine attack in the less hindered side, we will get a more substituted free radical, so it is more stable. After that again bromine is added and we will get the brominated cyclopropane, propane is obtained. Thank you.